Okay, so this is going to be the Unit 11A video. So the first part, well, actually, a lot of this will feel kind of like review, just slight extensions of what we've been doing recently, especially the area-related problems with the circles. So first part just is what are the formulas for, and then three basic shapes that we've been using all year. So area of a rectangle, you might remember, right? If it depends on how you want to refer to it. Let's say you have a length and a width, then the area, and remember rectangle, 4 right angles. So area of a rectangle is just length times width. Or if you prefer to think of it as a base and a height, then instead you'd have b times h. So however you want to think about it. Length, width, or base height. Okay, area of a triangle. Well, a triangle, right? You have a base and you have a height, and the area of the triangle is going to be half base times height. And if you kind of doubled this part and doubled this part, you can kind of see that you're going to end up with a rectangle there with that base and this height, which is the same. And then area of a circle we already know is pi r squared. Okay. So number 2, find the area of the trapezoid shown. And notice it says length are in inches. Give your final answer in exact form. So length are in inches, areas are going to be in square inches. So inches squared. So let's see, what can we do with this? If I chop it here, really what I've done is I've created two simple shapes, a rectangle on one side and a triangle on the other. And in this triangle, notice I've got a 60-degree angle, and it's a right triangle. So if I draw that guy by itself, here's 60. Hypotenuse is 12. This angle would have to be 30. So if I draw a basic 30, 60, 90 by itself right here, remember the three side lengths for 30, 60, 90. The short side is opposite the 30, that's a 1. Medium side is opposite the 60, that's a root 3. This side's a 2. And so then I'll call this well, I don't know, we'll just call them x and y. So if I set up some proportions, I've got 12 goes with 2, the same way that x goes with root 3. And if I cross multiply, I get 12 root 3 equals 2x. So divide by 2, and I get 6 root 3. And then separately, I've got 12 over 2 is the same as y over 1. Well, that just turns into 6 equals y. So right here, I know that this part is 6, and this part is 6 root 3. And then if I come straight across here, this part would be 6 root 3, and if I come straight down, this part's 15. So then the area of the trapezoid is really going to be the area of the rectangle plus the area of the triangle. Right? Area of the rectangle plus area of the triangle. Well, the area of the rectangle is 15, the base, times the height, 6 root 3. And then the area of the triangle is going to be 1/2 its base, which is 6, times its height, which is 6 root 3. So then 15 times 6 is 90. So that's 90 root 3 plus, and then half of 6 is 3, times another 6 root 3. So it's 3 times 6 root 3 is 18 root 3. And then 90 root 3 plus 18 root 3. If I have 90 root 3s and I add 18 more of them, I've got 108 root 3 right there. Okay, so the next one says, find the area of a regular pentagon with radius 10. Radius 10 means if you drew a circle around the pentagon, perfectly around it where it's inscribed, then the radius of the circle would be 10. So this is 10, and this is 10. So all these guys here are 10. So I'll draw them all into the corners here. So all those are radii of the circle. And let's see, we're working in centimeters for the length, which means the areas that we're looking for are going to be in centimeters squared. Okay, so we need, let's see, the area of the pentagon first. Then we're going to get the area of the region right here, these guys, eventually. So I'll shade those in now. Okay, so first the pentagon. And you'll notice with the pentagon, I really have 5 triangles that are all identical to each other. So if I could just find the area of one of these triangles, then I could multiply it by 5 and be done with the area of the pentagon. So the goal is to get one of these triangles done. Okay, whoop, of course. So I need one of these triangles. So let me draw that triangle by itself right here. These are the 10s. Okay, now this angle right here in the middle, notice there are 5 of them all the way around, and they're all the same as each other. So the total is 360, and if I divide it by 5, then I get one of those angles. So that's going to be 72 degrees right there. So each angle here is 72. So right here, this angle is 72. And now I need the area of the triangle. So the area of the triangle is 1/2 the base times the height. Well, let me draw a line right down the middle. And I'll call these guys x and this y. And then that 72 gets cut into 36 and 36. So now I could do sine of 36 is the opposite side of the hypotenuse. So then multiply by 10. And I'll get x. And if you plug that into a calculator in degree mode, you'll end up with 5.87785-ish. And the base is really 2x, so I'll double it. So that ends up being 11.7557. And then if I did cosine of 36 equals y over 10, multiply the 10 over, y ends up being 8.09017. So let me shrink this down just a little bit so I can fit some more calculations in here. So the area of the triangle then, this would be 1/2 the base, which is 11.7557, times the height, 8.09017, and that ends up being 47.553. So that's the area of one triangle, 47.553. But notice I don't just have one triangle, I've got 5 of them. So the area of the whole pentagon is going to be 5 times the area of the triangle. So it's 5 times this, and if you plug that into a calculator, you get 237.764. Now the last part says, what's the area of the region between the pentagon and circle? Well, this is going to equal the area of the whole circle, and then take away the area of the pentagon. Well, the area of the circle, here, I'll do this over here. Area of the circle is pi r squared, which is pi 10 squared. And if you plug that into a calculator, you get 100 pi, which is 314.159. So this would be 314.159-ish minus 237.764-ish. And then all that comes out to be 76.395 centimeters squared. Now, these problems are pretty frequent where you've got a regular polygon stuck inside a shape and you have to find various areas associated with them. So in the next problem here, I said, explain a step-by-step process for finding the area of a regular polygon with n sides, if you know the radius. So the idea is that you've got some polygon. You don't know how many sides it has. It's got n sides. So let me try to draw this a little bit better. Right? The idea is that you don't actually know how many sides it has. So let me shrink this down. So maybe this is side number 1, and this is side number 2, and this is side number 3. It's an n-gon, so the total sides it has, if it was like an octagon, then it'd be an 8-gon, right? If it was a decagon, it'd be a 10-gon. This one, so it would have 10 sides. Since we don't know how many sides it has, if it was 10 sides, this would be the 10th side. This would be the 9th side. But since it's n sides, this is just n. And this would be whatever came before that, 1 less than n. That was not as important. Okay, so let's say here's the center. So the first thing that we did in the previous problem for finding the area was we drew in all these radii and we sliced it up into 5 triangles because it had 5 sides. So in this one, we're going to cut the polygon into a bunch of triangles. And if you think about how many triangles you get, you're going to get 1 triangle for every side. So if there are n sides, there are going to be n triangles. N triangles using the radii. Now remember, we know in this problem what the radius is. So I'm going to mark them all as though we know them. They're all r, whatever r is. Okay? So the next step that we did, let's see, what did we do second? The next step we did was we found the central angle. Right. So find the measure of the central angle, which was 360 degrees divided by n. It was how many angles are in here? Well, there are n of them. So if you just divide 360 by n, you'll get 1 of them. Okay? Then after we got the angle, we slice that triangle right down the middle. Right? So take 1 triangle and cut the triangle in half with an altitude. Right? So it forms 2 right triangles. So I'll draw that here. So that was like when we did this. Okay, so I'll even label these x's and y's. Okay, so use trig, then we use trig to find x and y, where 2x equaled the base and y equaled our height. Then we found the area of the triangle. So once we had the base and the height, then you can just use the formula for area of a triangle. Use area of triangle equals 1/2 base height to find area of 1 triangle. But then remember, in the previous problem we had 5 of them, so we had to multiply by 5. In this one we have n of them. So multiply area of triangle by n to get area of the whole polygon. And there we go. That's if it's a regular polygon. Okay? Notice in this next problem, it's not a regular polygon. The angles aren't all the same and the sides aren't all the same. But it is on a graph. And we learned a while back that if you've got a picture on a graph, you can find its area by drawing in these easy shapes around it instead. So slope triangles, once again, are going to come in handy for a problem like this. And really what we've got is we've got a big rectangle to work with. So if I found the area of the whole rectangle and then got rid of these 4 right triangle areas, I would just have the area of the shaded region, the polygon that's originally there. So what I'm going to do is I'm going to call these, I'll call this region 1, triangle 2, triangle 3, and triangle 4. And let's find the lengths of these triangles. So when I go up, the y's change from 0 to 5, so it's 5 up. I go from -6 to 2 across here, so this is going to be 4 across. This one goes -2 to 4, so that's 6 across. And 5 to 1 is 4 down. And then 1 to -3 is another 4 down. This will be 1 over. This will be -6 to 3 is 9 across. And then, let's see, 0 to -3 down will be 3 down. So they're all my length. So then the area of the big rectangle, right, the big rectangle, well, it's 8 by 10. So it's 8 times 10 is 80. And then area of triangle 1 is going to be 1/2 base height. And since it's a right triangle, we can think of the 4 as the base and the 5 as the height. So 1/2, 4 times 5, which is 10. Area of triangle 2 is going to be 1/2 its base, 6 times 4. So let's see, half of 6 is 3. 3 times 4 is 12. Area of triangle 3 is going to be 1/2 3 times 9. Let's see, that'll be half of 27 is 13.5. And area of triangle 4 is going to be 1/2, let's see, 1 times 4. So that's just 2. So if I put all these together, the sum of the triangles, sum of the areas of the triangles, by the way to write sum is like that. It's the sum of the area of the triangles. That ends up being 31.5. This, by the way, means sum. Sum of, right? So, what I want to do to get the shaded region, the area of the polygon, it's going to be the rectangle, and then take away the 4 triangles, and that ends up being 48.5. We got one more problem down here, number 6. It says find the area of the parallelogram. Well, we don't have a formula for area of a parallelogram yet. Notice if I were to, I don't know, let's say make a rectangular shape here, this triangle is going to be the same as if I just chop off this triangle and move it to there. You see that? Well, here, let's look at this. The angle up here is 121. Well, you might remember parallelograms have top and bottom parallel. This is parallel. And these angles right here are same side interior, so they have to be supplementary. So 180 minus 121 is 59. So this angle down here is 59 degrees. Okay. Let's calculate the height right here. So I'm going to call that x, let's say. So if I use this right triangle right here, I know that I've got an opposite and a hypotenuse. So sine of 59 is x over 5. So if I multiply the 5 over, then we get 4.2858. 4.2858. Well, that's this, 4.2858. And remember, if I cut this off, this triangle off, and I put it right here, then instead of the full parallelogram, now what I have is this rectangle right there. And I know that the base of the rectangle is 9, and the height of the rectangle is 4.2858. So if I just multiply those two guys together, then I end up with the area of the parallelogram, 38.573. Let's see, if these are centimeters for the length, then the area is centimeters squared. So it actually turns out that by doing this, we derived the formula for area of a parallelogram. If you have a parallelogram, the formula for area of a parallelogram, it's still base times height. The problem is students think that if you have, problem is students think that this is the base, which is fine, that can be the base, but they think that that's the height, which it's not. The height is the distance between those parallel sides. This is the height, and this is the base. And the reason that it works, it comes from taking this triangle on one side and moving it over to the other side. So the height of the triangle is the height of the rectangle, and then the base of the parallelogram is still the base of the rectangle that you get right there. Okay? All right, so I hope that helps a little bit, and I'll see you guys soon.